Okay, so I'm going to go through the presentation again for our online certification study group. So to work through this presentation I have here, talk through the topics that will be covered, and then go through some sample questions, and then open the floor up to questions, any questions you can think of. And then I also have a drawing pad here. I can either draw MongoDB drawings for you, or I can draw rabbits and things like that too, depending on what you're interested in. So my name is Jason Zucchetto. I've been at MongoDB for about 3 years as a consultant engineer and now a curriculum developer on the education team. I've worked with over 100 companies. I've seen every single MongoDB sort of issue you can encounter, and different cluster sizes, and you name it. Clusters with hundreds of shards, and from Fortune 10 companies to small startups. So let's go through this, our certification exam agenda, and I'll talk about the structure of the exam, topics covered, some sample questions, and then answer some Q&A. Let's talk about the structure of the exam first. And then what I'm going to do is try to save more of the questions till the end, and then just get to the whiteboard and answer more questions that way. The real goal of the certification exams is to certify individuals that we have confidence in them working with MongoDB. So there's a large number of companies that I even individually work with that are looking to hire lots of people that either manage or develop on top of MongoDB, and we need some. This is sort of the mechanism to make sure that we have that we're confident that they can monitor those MongoDB servers. And so the exams are built to recognize developers and DBAs with proficiency to build, deploy, and manage applications on MongoDB. The exam structure, there will be a exam proctor virtually that will watch you take the exam. So this is a virtual proctor. They're not going to come to your house or apartment and watch you take the exam, but they'll have a video camera and watch you take the exam. And you'll also need a microphone and a headphones to listen to. You need some form of identification to make sure we can verify it's you. So it might be a passport, national ID, driver's license. We need to make sure the face is very clear. No blood samples are required yet. No. And ensure that we can see your passport or your photo, and it's clear. I talked about how the proctoring works a little bit, but there will be a camera that watches you take the exam. This is it's not allowed for you to navigate to websites or look at our documentation, or IM your friends that may know the answer, or post something on Stack Overflow or Google Groups, put something on Twitter, these things to find the answer. So no surfing's allowed, no using other materials are allowed. And with the exception that Google Translate is allowed. So if English isn't your first language, you can use Google Translate to take the English description and translate it to another language. So the exam structure, multiple choice questions. It's all multiple choice. Some will either have one correct option, or others will have multiple correct options. There's no free text form where you can write code, or you won't need to use a shell prompt or anything there. It's all going to be multiple choice. There's no partial credit, and there's no penalty for incorrect answers. So you want to make sure you at least guess on every answer, even if you don't know the answer, because there's no penalty for incorrect answers. You have 90 minutes to complete the exam. So let's go through some topics. I'm going to focus now on the DBA side. So earlier, I went through developer and DBA and sort of went through all the topics that can be on the exam, and then talked about which ones were more specific to developer and which ones were you can rely less on as a developer, and then which would come up more on for the DBA side. So now I'm just going to focus on the DBA side. So it's the right column here. So you want to make sure you definitely know the fundamentals of MongoDB. So what is JSON? The JSON spec. How many different data types does JSON support? So it's if you look at if you Google JSON spec, you'll see that the JSON spec. You'll see there's 6 types it stores, and that wasn't enough for MongoDB. So we needed a date type. We needed a binary data type. There were some additional types we needed that JSON didn't have. So we extended JSON and created a binary form of JSON called bson. And you need to know what bson is and some of the details around bson. So you could look at bson-spec.org to learn more about bson and what it is. It's really how MongoDB stores all of its documents. So MongoDB doesn't store anything in JSON. JSON's if you stored a JSON string, you'd have to walk the entire JSON structure to find a field. It'd be very inefficient. So you need a binary representation of JSON, and that's bson. And so a document, if you're working with a driver and it's talking to a database, and then you're moving documents back and forth, nothing's actually getting converted to JSON. Everything's in maps or on the driver side and bson on the server side. Most of the time. You could convert it to JSON on the driver side, but you'd have to explicitly do that. Also, fundamentals, maximum document size of MongoDB, 16 megabytes. So remember that. Starting up MongoD, there's a bunch of options you can specify, -- small files, DB path, what is the default database path, which is /data/db. And so knowing these command line options for the MongoD instance. Also, how do you start the shell? So you can start the shell and point it to a MongoD instance, but what are the options there? How do you specify a database to connect to or a host? So if you do mongo -- help, you can see the options there. For the DBA exam, it's definitely lighter on the CRUD section and aggregation. So know the basics of each, but you won't need to know it in depth as you would for the developer exam. So for instance, inserting a document, how does that work? How do you create a database? How do you create a collection? How do you find a document? How do you update a document? How do you remove a document? How do you drop a collection? How do you drop a database? These sort of basic things that a database administrator would need to do. So in terms of CRUD and aggregation, this it's definitely not going to be as in-depth as developer. So just sort of make sure you know the basics here for querying the database. So indexes, make sure you know how to create an index, a single field index and a compound index. Know what a multi-key index is. So if you index a field of array elements, that's a multi-key index. And then the trade-offs in a single field index versus a compound index. If I have a compound index on the fields A, B, C, I could use that index for queries on A, queries on AB, and queries on ABC, but I can't use that index for queries on C or BC. So to use a compound index, you need to use every field from left to right within your queries. Now, the order of the fields within the query don't matter. The query optimizer will handle that. But the order of fields within an index definitely do matter. Also, in regards to indexes, make sure you know how to use explain and the considerations there. So what fields do you want to look for when you're optimizing a query with .explain? Actually, yeah, for Ray's question, no, I agree with Stefan. You want to make sure that you're staying safe, and so we'll make sure to accommodate whatever you need there. So let's continue with indexes. So the explain output, how do you use the explain output? How do you analyze it? What are the fields in the explain output mean? So there's a lot of fields in the explain output. And so just look at the top level fields within execution stats output. And just to back up for a second, there's 3 modes of explain. There's the default mode, there is execution stats, and then there's all plans execution. And so you have, just make sure you know that there's 3 modes for explain. And with 3.0, you can now explain write operations. So you can explain updates, removes, aggregate, count, find. And so the explain functionality was actually completely rewritten between 2.6 and 3.0. Replication. So replication and sharding, I would make sure you at least know how to set up a replica set, and you know how to set up a sharded cluster. So for replica sets, make sure you know all the components of a replica set, the role of each node in the replica set. So you can have a primary, a secondary, arbiter. What are their roles? How do elections work? So remember that you need to have a majority of nodes to be available to have a primary. And so these sort of basic concepts of replication in MongoDB, how do votes work? How do nodes vote within an election and determine who the new primary should be? How the oplog functions and works. So remember that the oplog is idempotent, idempotent. So we don't replicate the operations that came in, we replicate the result of the operations that came in. So if I increment I by 100 and I was 1 before, the oplog statement is not I equals I plus 100, it's I equals 101. And so we replicate the result of the operation within the oplog. And this helps a lot with rollbacks and some other scenarios because we can replay the oplog operations and still get into the same state. And so if we kept the actual operation that came in, if we replayed the same operation multiple times, we'd have a database in a different state, depending on how many times we replayed it. So it's important to remember the oplog is statement-based and stores the result of the operation that came in. For replication, make sure you know details of the write concern. So you can write to multiple nodes. So it's single master system. You can only write to the primary within a replica set, but you can wait. You can have the primary wait for an operation to replicate to multiple nodes before it returns success to the driver. So the default is W equals 1, which means confirm the write occurred on the primary. I can say W equals 2, and then it'll wait for the write to occur on a primary and at least 1 secondary. I can say W equals majority, where it confirms it on a majority of the nodes in a replica set. So know the details of the write concern and the options there, especially in regards to replication. Read preference, to know what the read preference is. There's 5 read preferences: primary, primary preferred, secondary, secondary preferred, and nearest. Nearest will wait every node equally within 15 milliseconds ping time. So that helps with the cascading blackout scenario where if it didn't do that, all the reads would just go to the node that's 4 milliseconds away, then 5 milliseconds away, and it would just go through all the nodes. So by default, it weights every node equally that's within 15 milliseconds ping time. You can adjust that setting. You can make it 100 milliseconds, but the important thing here is remember there's 5 read preferences, and nearest uses the 15 millisecond ping time threshold that can be adjusted. You can also pass in tags to a read preference. So I can tag a node as being in the San Francisco data center, and then I can do a secondary read preference and say from data center San Francisco, and it will go send the read directly to that node that's tagged with a certain value. So know how tags work with replica sets and read preferences. Sharding. So know all the components of a sharded cluster and how that works. So there's lots of components. There's a config servers. The config servers are not a replica set. You can either have 1 or 3 config servers. You have a Mongo S instance, which doesn't persist any data. It doesn't require a database path. It's essentially a router. It's the queries to one of the shards. And then each shard can be a standalone MongoDB node, but ideally it's a replica set. To know all the components of a sharded cluster, know how balancing works, how do chunk splits occur, what are chunks, the default chunk size is 64 megabytes. Should know that. Shard keys, what is a good shard key, what makes a good shard key, how can you get a hot shard? So you can have a shard key with an increasing value, and since we do range-based partitioning, you'll always hit the top of the range, right? So if you have a shard key with an increasing value and you're trying to target a high insert workload, and you have 100 shards, you're only going to hit one of those shards because the increasing value means you hit the top of the range, and so all your inserts will just go to one shard, and you get this hot shard. That's called. I didn't make up that term, by the way, but hot shard is the expression for it. Let's see. So that is sharding. Hash-based sharding. You also want to know the basics there. Let's look at administration. So the DBA. So it is. So there is a term called a hot shard. I don't think it's in our documentation, but that's sort of what's referred to when you have a shard that's getting the majority of the traffic. So it's considered a hot shard. It's hot. It's you're not distributing your traffic over all the shards. And I would just talk about hash-based sharding. So how that works, how you can create a hash-based or a hashed shard key and the limits there. So there's no compound hashed shard keys today. So you can only do single field hash shard keys. So administration, operation, backups. So know the steps to back up a sharded cluster. Know the steps to back up a replica set. So considerations there. Restoring a sharded cluster, there's a specific set of steps to restore a sharded cluster. Server administration. So the compact command, the repair command, what the difference is between repair and compact. So repair will rewrite the data files and will actually reduce the data file size. So if I have 100 terabytes of data files and then I've had so much fragmentation that I only have 10 gigs of data, if I run repair, my data file size will be 10 gigabytes after I run that repair. But if I have 100 terabytes of data files and 10 gigabytes of data within them, because I have so much fragmentation, I run compact, my data files won't go down at any in size. It will just compact the documents so they're together and not fragmented across all the files. So a question just came in, what's the max number of documents for a collection? So there's no maximum amount per collection. So there's clusters with petabytes of data, so they get very large. With the mmap storage engine, there is a maximum database size per instance. So that's 128 terabytes. And then since you have a private view and a public view, it's actually 64 terabytes of data per instance is the maximum with the mmap storage engine. But ideally, you never have a shard that gets gets even close to that. You would split data across shards well before you even got to that limit. So with sharding, there is no theoretical limit. And let's see, server administration. Since it's now, so actually this is a good question for this topic because now we can talk about storage engines. Since this is now for 3.0, how much do we need to know about WiredTiger as well as compression options? I would say definitely know the basics of WiredTiger. You don't need to go into detail in terms of how WiredTiger works. So to quickly go over those details, there's two storage engines now in 3.0. There's actually an undocumented third storage engine, but you don't need to know about that one. So there's the memory map storage engine, which uses memory map files. And then there is the WiredTiger storage engine, which will be the default storage engine in 3.2. So we just announced yesterday that with 3.2, MongoDB or WiredTiger will be the default storage engine. You don't need to know that for the exam, but that just shows you the confidence level we have in the storage engine and what we're seeing in terms of numbers and how it's performing. The differences here is make sure you know that WiredTiger has document level locking. mmap has a database level lock. So you'll see much better concurrency with WiredTiger than mmap for most write workloads. So you get that document level concurrency. So make sure you know that. And then WiredTiger also has compression. So by default, it uses snappy compression, but there's also a zlib compression option, or you can see no compression. Snappy doesn't compress as well as zlib, but it uses less CPU than zlib. If you use zlib, it uses more CPU and compresses the data even more, but then you get the hit on CPU. So snappy is the nice mix between the two. And there are a very small handful of WiredTiger options you can use, like cache size, so you can control the amount of RAM that the MongoDB process uses. I'd say these are sort of the basics I'd want to know for the certification exam. And then I see, now that you told us about it, what is it? There's a experimental in-memory storage engine that was also part of 3.0, but it's being completely rewritten for 3.2. So we're going to release an in-memory storage engine with 3.2, but that's being completely rewritten from the one you see in 3.0 that's called experimental something. So that's what it is. But you don't need to know about it, so just forget I said it. Does WiredTiger support ACID with document level locking? So we're atomic on the document level where you can never get a document in a dirty state. So you can never get a document in a half written state. So WiredTiger actually supports WiredTiger supports transactions, but we don't expose it within MongoDB. So that sort of gives you a hint maybe of what could happen in the future. But our storage engine supports transactions, but MongoDB doesn't. So it's there within WiredTiger. You can go to wiredtiger.com, I believe, and learn more about it. Let me just double check that URL. Hopefully it's a storage engine related one. Okay. Yeah, so wiredtiger.com will tell you more about the storage engine, and then you can see the docs and read through it. And it does support transactions, but we don't expose any of them. And it's going to be some time before we have transactions within the database, multi-document transactions. But to answer your original question, you can never get a document in a dirty state where it's halfway written. It's all either fully committed or not committed. So, I've been referring to Christina Chartereau's book. Do we have a revised book for MongoDB 3.0? I don't think there is a good book for 3.0 yet because 3.0 is so new. So, yep, sorry. So the question is, how about security? Will that also be included? So know the basics of security. So you can use SSL, but we don't expect you to know the details of a SSL implemented cluster. So very high level security topics, I say, could come up, but you don't need to know the low level details of whether or not you should use a certificate authority file for your cluster, or you may want to know that you can use X509. Sort of an example question may be, you can use the X509 certificate for cluster authentication between nodes in a replica set, or you can use a key file. And those are your two options there for inter-cluster authentication, verifying the node is part of the cluster, but nothing sort of low-level details beyond that. Okay, so that's server administration, monitoring and troubleshooting, MongoStat, MongoTop. Sort of if you Google MongoDB production notes, you can see all of our production notes for the machine. Make sure the U limits are correctly set on the machine. Our very first support case was related to U limits, like almost 7 or 8 years ago. And then to this day, we get ulimit support issues, and so we want to make sure you set up the ulimits correctly, the user limits on the machine correctly. NUMA is really bad for the random access patterns of a database, so you want to make sure that if it's a NUMA enabled machine, that you don't you disable NUMA for the MongoD process. And yeah, some basics, that you can use MMS, but nothing detailed about MMS. So let's go through some sample questions here. Okay. So when I want to scale up my read operations, I should do, tag-aware shards. Tag-aware sharding could come up. So how do you, what is tag-aware sharding? You can tag shards. How do you create ranges for tags? That could be on the test. So if I want to scale up my read operations, I should, and ideally, if you scale by increasing the size of a replica set, there's a lot of downsides to that. So first of all, you have to deal with the eventual consistency if you read from secondaries, and that can be difficult to develop against. From a capacity planning perspective, if you scale via replication, if you lose a node within the replica set, you've lost some percentage of your capacity. So you don't have the same level of capacity as you had before. And so if you scale via sharding and you lose a node, you lose a primary, you have another secondary that would take over, and you have the same exact amount of capacity as you had before. And that's the preferred approach to scale reads. So the answer to this one is add shard nodes over adding secondaries in a replica set for scaling reads. So example of a benefits of MongoDB for representing a one-to-many relationship include which of the following? So this is an example of a multiple choice question. So you can check many of these. So in many situations, it's better to model your data so that while there is a random I/O operation seeks for each parent entity, the data for children is read sequentially. Avoid storing relations by embedding into a single document one-to-many relationships. You can keep the entities in separate collections, but still query and aggregate them together. So there's no joins in Mongo. And so you can easily strike out the third one, right? Because you can't query across collections yet. So 1 and 2 are correct in this question. Let me answer this one. Create users, roles, etc. From the chat. Yep. Yeah. So definitely make sure you know how to do that. Sort of basic user administration. There's built-in database roles like DB admin any database, and it's I think a little confusing sometimes that when you do DB admin or user admin any database, that the only thing that person can do with that role is create other users. They can't read everything or write everything. They're not a super user at that point. So knowing those high level roles and what they can do specifically, so that'll definitely be useful. Okay, next question. So given the following document, it's ID A with a subdocument, can we achieve covered queries using the following index, A.B:1. So just to back up, a covered query means that you're returning all the results directly from the index, and you don't have to actually go to the documents to return those results. So you can use projection to make sure you only return the fields that are contained in the index. And you'll see the second answer here excludes the underscore ID and just returns A.B. And so A.B, the index is on A.B, and the second query just returns A.B. And you have to explicitly say underscore ID equals 0 because every query always returns underscore ID, and that would cause the database to look at the documents. So if I wanted to return the results directly from the index, I would specifically exclude the underscore ID field. But you can't do covered queries that are not on root fields. So the last answer here is the correct answer. No, because you can only do covered queries on root level fields. So you can't do covered queries on fields within a subdocument. So make sure you know that. Let me scroll down here to show you the answer, and then I'll answer that question. Whoops. Does the future courses of M112, M22 cover more about MongoDB 3.0 features like Ops Manager, WireTiger? If yes, any ETA? So 102, there's some videos that were added for WireTiger. We'll probably do a course on, we don't have dates yet, but we'll probably do a course just on Ops Manager in the future because there's so many topics there. And then ideally, there's some more options coming out with WireTiger with the next version that will give us a lot more things to tune and work with. And so it may make sense to do another course on WireTiger alone, but we need to add a lot more content for WireTiger. Right now there's sort of basic videos about how WireTiger works within the courses, but we don't really go into depth, the technical details of WireTiger yet. So no ETA, but yes, we need to cover these topics as soon as possible. Okay, next question. Which of the following statements are correct for a delayed replica set node? I can run backup operations on a delayed node in a replica set. Yes, definitely can do that. In the case of failover, delayed replicas can assure the primary role. No, because they're always delayed behind other nodes in the cluster by some amount of time, and they'll never be able to be primary. Delayed replicas prevent application data corruption. That's true. So we use replication to have multiple copies of the data. It gives us insurance that if a node fails or a hard drive crashes or a machine fails, that we have multiple copies of it, and also prevents against corruption. So bad disk sectors, we can go to another node in the replica set, and then we can get the document from there. Or if you're not using a RAID configuration potentially in that scenario. So the answers here are 1 and 3, and we can leave out 2. And that's another example of a question with multiple answers. I can't see the sample question. Can you see my screen? Hopefully I've been sharing this whole time. Okay, good. As long as Bill can see it, we're okay. Okay. Oh, we got 2 people who can see it. That's good. Okay, we have 3. Ray can see it. I think we're all set. So let's go to the next one. Back to Lewis. Do you think it may be a connection? Maybe it's just slow to update potentially, but okay, good. Thank you. Okay, so which of the following most accurately describes a cursor? So a cursor, when we create a query and we send it to the database server, it creates a cursor, which is where all the hard work takes place. So it needs to look at the index, figure out where the documents live, and then it creates this cursor, which is essentially just a pointer to where the results are. So the answer here is a pointer. That's really what a cursor is. It's not a document. It's not a collection. It's not an array of documents. It's a pointer essentially. So if I scroll down, see a pointer as the correct answer here. Okay, so those are the sample questions. Let's go into any questions you may have, or if you just want me to draw pictures here on the board, let me know. I'll see what I can do. Any questions about MongoDB, topics you may want me to cover? Do we need to know about GridFS? Just the basics, so not in depth. So just how good, why you'd want to use GridFS. So it's storing files in the database. The advantages there are you can use replication, you can use backups for the files that you store in the database, and then GridFS uses two collections to track those files. One is files collection, and one is the actual binary data. So the files collection has the metadata about the files, and the other collection has the binary data for the files. So just the basics on GridFS, I would say. Let's see. Should I also learn advanced DBA? Do you mean the 202 course, Oracle DBA? Oh yeah, yep, 202. No, I think 102 is sufficient here. So as long as you know 102 in depth, you know all the topics, I think that's fine. I don't think 202 is required for this. Michael, how can you store documents larger than 16 megabytes? You can't. So think about a 16 megabyte limit as like a row in a relational table. And when you get a 16 megabyte row, it's pretty large. It's a lot of text. So 1 megabyte of text is about a 300-page novel. And so when you have 16 megabytes, it's like 16 300-page novels. It's a lot of information to store. Usually get into that when you're storing like binary files, and we have the GridFS implementation for storing binary files in a database. But if you get in the scenario where you're getting close to that 16 megabyte limit per document, you're usually doing something wrong on the schema design side. Oh, okay. So just to recap on that, GridFS will split the file up. So if I put a 100 gigabyte file into the database, GridFS will split it up into chunks and then store all those chunks in the database as with a default chunk size that can be adjusted. And so maybe I want to use a 256K chunk size, so it'll split my 100 gigabyte file into smaller chunks and put that in the database. Let me just make sure I get out of order.
Hello, do you hear me?
Any questions about journaling mechanics? Yes. So make sure you know the role of the journal, why it's there. The journal is really for crash recovery. So when write makes it to a journal, it's considered safe, and the journal is appended to asynchronously every 100 milliseconds. and you can configure that on the MongoD command line by specifying the journal commit interval. Ray, I don't, GridFS, just know the basics of it, but nothing in depth there for the developer exam. Let's see, any other questions regarding any of these topics? Okay, it seemed to drop between the 2.6 and 3.0 M101J version. So what do you mean it dropped, right? And then Javier, to store, say you wanted to store video files. So I work with a few companies that actually store videos in MongoDB, and GridFS is actually ideal here for storing videos in MongoDB because it'll split the video up into smaller chunks. And when, say you split a video up into 200K chunks, now it becomes easier to stream 200K chunks down to like a mobile client because I can keep track of which chunks were sent to the mobile client, and then I can send one chunk at a time, and I don't have to sequentially go through the file to get to the last position the client was at. And so the companies I've worked with where we've stored videos in the database, we've used GridFS for that. And oh yeah, so Ray, yep, GridFS wasn't covered in the latest M101J. Yep, that's correct. The audio, is there a dress code? Hey, it's you have to wear a tuxedo for the exam. It's
That's exactly what I was going to say, Jason.
Just kidding. I don't think there's a dress code.
No, there isn't a dress code.
I think clothes are required. I don't think
just a t-shirt.
Okay.
So 90-minute test. There are 60 to 70 questions. So each question, imagine you want to spend about a minute and a half on each one. Sure. Can we use paper and pen to aid thinking? I'm not sure the official rules there. Let me double check. Nayati may be able to answer that. Okay, there we go. Thank you. Arun, yep. Yeah, so it'll say select multiple or select one. Bill, no ops manager topics on this one. Okay, let's see. Any other, you're welcome. How about mtools, any topics? Know that mtools is a possibility for diagnosing queries and bad performance, but no, we're not going to go into the details on how to use mtools or any of the options there. So I wouldn't, as long as you know, even, no, there should be nothing related to mtools on there, but knowing about mtools is only a plus. Off topic, any plans to support SQL? What is SQL? I'm not sure what that it is. So you know, there's some plans for. We just announced a connector for BI integration. So SQL is very important for some BI tools out there, and there's a few connectors that are available today, like Simba, a few more, but they're not great. There's a good company out there called Slam Data that turns SQL queries into aggregation queries in MongoDB. They have some pretty cool stuff to look at. Slam Data, yep. Just want to get the cert on the CV. Hell out of where I am. Just curious, where are you, Ray? Sure, I'm glad you found it useful. Yeah, they have a cool presentation. I like their platform. Okay, we have Thanks, guys. Good night. Thank you. Okay, I think this is a good time to wrap up the session. And thank you, everyone, and best of luck. And hopefully everyone passes. Thanks.